In this series of videos, we're going to talk about graphing linear equations using intercepts. So this idea of intercepts is going to come back in multiple ways as we work through this class, and then again when you all get to a pre-calculus class. So really understand the basics here when we're talking about lines, because again, these same ideas, you'll see them over and over. So first, really quick, let's kind of talk about what intercepts are. So definition, intercepts are points where a graph crosses or touches the x or the y axis. So a point where a graph crosses the x-axis is called an x-intercept and is of the form x comma 0, okay? And then a point where the graph crosses the y-axis is called a y-intercept and is of the form 0y. So let's go and look at this kind of separately. We need to remind ourselves of this idea of the Cartesian plane. So I'm just going to kind of sketch this here. I'm not going to make it super perfect. But we had this idea of the Cartesian plane, okay? We knew that the Cartesian plane was made of an x-axis, which is a horizontal number line, and a y-axis, which is a vertical number line, and they intersect at something called the origin. So that was all pretty straightforward, nothing too crazy, okay? This was broken down into 4 quadrants. We had quadrant 1, quadrant 2, quadrant 3, and finally quadrant 4. Now, when you're looking at a graph on the Cartesian plane, a graph could touch the x-axis or specifically the y-axis. It could touch it or it could cross it. That would be an intercept. So if I'm over here, this point right here, okay, that point is on the x-axis. This would be an x-intercept. And really pay attention to what the ordered pair is. In order to get to this point, I would have to go to the left 1, 2, 3, 4, 5, 6. So this would specifically be -6, but then I don't go up or down. If I go up or down, I'm not on the x-axis anymore. So in order to be an x-intercept, I have to be on the x-axis, which means I have to have a y-coordinate of 0. So x-intercepts must have a y-coordinate of 0. And that is a really important fact because that's how we're going to find intercepts in a future video. Now, if I were to live over here, let's say, to get to this ordered pair at the origin, I would not go left or right. I would just go down 1, 2, 3. So this point would be 0 for x and then -3 for y. So notice I live on the y-axis. That means I'm a y-intercept. And the ordered pair has to have 0 for x. If I have anything other than 0 for x, I'm either to the left or to the right of the y-axis. I'm not on the y-axis. So y-intercepts must have an x-coordinate of 0. So pause the video, make sure you get that written down, make sure you understand it. Let's go back to the original worksheet. Okay? So hopefully now when you see this right here, you understand what I was getting at. So an x-intercept always has to have an ordered pair that has some x-coordinate, positive, negative, whatever, but the y-coordinate has to be 0. For a y-intercept, the ordered pair has to have 0 for the x-coordinate, but then y can be some positive or negative value, okay? So just understand, generally speaking, what an intercept is. So topic 1 is identifying intercepts. So we're going to look at a table, and we're going to look at a graph, and we're going to figure out what the intercepts are. So we will learn to identify intercepts from a graph, a table, and eventually an equation. The next video we'll talk about an equation, okay? All right, so the first one, it says part A, use the graph to find the intercept and the x-intercept and the y-intercept. Okay, so the x-intercept is going to be the point where we touch or cross the x-axis. The y-intercept is going to be the point where we touch or cross the y-axis. So let's start with the x-intercept. Well, that would be this point right here. So that's our x-intercept. A lot of times I'll abbreviate it to just x-int, okay? And to get to that ordered pair, I would have to go to the right 3, but then I stay there. I don't go up, I don't go down, so my y-coordinate is 0. All right? Now, the y-intercept is right here. And again, a lot of times I'll abbreviate it to just y-int, okay? Now, to get to that ordered pair, my x is going to just stay 0. I don't go left or right from the origin. I would just go up 5. So there's my x-intercept and my y-intercept. Now, looking at a table, we have to recall, x-intercepts are always of the form some x value with y being 0. And a y-intercept is always going to be of the form 0 for your x-coordinate and then some y value. So looking in the table, look to see where x and y are zeros. So if I look right here, that's my x-intercept. If I look right here, that's my y-intercept. So I know that my y-intercept is the ordered pair 0, -4, because to be a y-intercept, I have to have an x-coordinate of 0. And then my x-intercept is going to be the ordered pair 10, 0. In order to be an x-intercept, I have to have a y value of 0. So there you have it. From a table of value, we found our x and our y-intercepts. Now, I was originally going to make a second video for this next example, but I think we've got time. This will be a nice link. So let's go ahead and look at finding intercepts from equations. Okay. Now, when you have an equation, you've got to do some work to get your x-intercept. It's not quite so obvious as it is from a graph or a table of values, but it's still not hard to do. So in order to find x and y intercepts from an equation, to find the x-intercept, let y equal 0, and then solve for x. And then to find a y-intercept, we let x equal 0, and we solve for y. And then this is really important right here. This is kind of my own personal pet peeve. Write your answers as two distinct ordered pairs. Students make this mistake all the time. They take the x-coordinate from the x-intercept, they take the y-coordinate from the y-intercept, and they try to make a single point. Well, that point no longer lives on the x or the y-axis. So make sure you write your ordered pairs as two distinct ordered pairs, or specifically x-intercept, and then write the x-coordinate, y-intercept, write the y-coordinate. I prefer the ordered pairs. Okay, so let's go ahead and look at these three examples. All right, so it says, for example, to identify and label all intercepts, label them. Make sure you tell your teacher, your reader, that you know what's the x-intercept and what's the y-intercept. Okay, so let's look for the x-intercept first. So I'm going to do the x-intercept. So in order to find an x-intercept, I let y equal 0, and then I solve for x. So this is just like what we did in a previous worksheet where we were finding solutions to linear equations. We're basically just finding a solution. We're just finding a very specific solution called the x-intercept. So I take 3x plus 5 times 0, so 5y, y is 0, equals 15. Well, 5 times 0 is just 0. 3x plus 0 is just 3x. So I get 3x equals 15. I divide both sides by 3. That'll undo that multiplication of 3 and x. 3 divided by 3 is 1. 1 times x is x. And then 15 divided by 3 is 5. So I don't like x equals 5. You'll find out later why. Either say x-intercept is 5, or say x-intercept is 5, 0. Okay, don't write it like this because that means something else in math. Okay, so either label it x-intercept is 5 or x-intercept is the 0.50. Now for the y-intercept, we would let x equal 0 and then solve for y. So again, we're finding just a solution to this equation, just very specifically the y-intercept. So we get 3x plus, don't do 3x, do 3 times 0 plus 5 times y is 15. Well, 3 times 0 is just 0. 0 plus 5y is 5y, which equals 15. We need to undo the multiplication of 5 and y, so I would divide both sides by 5. 5 divided by 5 is 1. 1 times y is y. And then 15 divided by 5 is 3. Again, I don't like this version. Y equals 3 means something. So either put x-intercept. Shoot, don't put x. Bless my heart. I'm having trouble this morning. Put y-intercept is 3, or even better, my preference is the ordered pair. I like the ordered pair 0, 3. So there you have it. It's not terribly difficult. Plugging in zeros is easy for us. So it's really just something you can almost do in your head if you have a nice, pretty equation like this. Okay, let's look at part B. So part B, we have negative x plus 3y is 8. Let's start with the x-intercept again. Now to get an x-intercept, you let y equal 0. Always let the opposite variable equal 0. So I get negative x plus 3 times y, which is 0, equals 8. Well, 3 times 0 is just 0. Negative x plus 0 is just negative x. So negative x equals 8. But remember, when we have a negative in front of a variable, it means negative 1 times whatever that variable is. So this is really negative 1 times 8. So I need to divide both sides by negative 1. Negative 1 divided by negative 1 is just positive 1 times x. And then 8 divided by -1 is -8. I don't like this version. This means something else, which we'll learn about soon. So we would say the x-intercept is -8, or even better, I like the ordered pair. Okay, so that's the x-intercept. Now the y-intercept, very similar, but we let x equal 0. So I get -1 times 0 plus 3y equals 8. Well, -1 times 0 is just 0. 0 plus 3y is 3y. So 3y equals 8. And then I want to undo the multiplication of 3 and y, so I divide both sides by 3. 3 divided by 3 is 1. 1 times y is y. And then leave it 8/3. If you could simplify, like if 8 and 3 had a common factor, simplify it, but do not write it as a mixed number. Don't write it as a decimal. Just leave it 8/3. All right. And remember, I don't like that format because y equals 8/3 means something different. So we would want to put y-intercept is 8/3, or like I've already told you, I prefer the ordered pair. Okay. Now, part C is a little tricky. It's not tricky, it's easy to do, but you have to think about what's happening here. So we're going to go ahead and just go through the motions here. We're going to find our x-intercept, which means we let y equal 0. So I get 7x minus 9 times 0 equals 0. Well, 9 times 0 is just 0. 7x minus 0 is 7x. So I get 7x equals 0. Well, if I have a product that equals 0, one of the two factors at least has to be 0. So that means if 7's not 0, x has to be 0. But further, we could just divide both sides by 7. 7 divided by 7 is 1. 1 times x is x. And 0 divided by 7 is 0. So I could say the x-intercept is 0. Which over here, we already let y equals 0, x equals 0, so it's kind of like, all right. Let's go ahead and just do the problem to find the y-intercept. So this time I'm going to let x equal 0. Excuse me. So I get 7 times 0 plus 9y equals 0. Well, 7 times 0 is 0. 0 plus 9y is 9y, and 9y equals 0. So again, if you have a product equaling 0, one of the factors has to be 0. 9's not 0, so that means y has to be 0. And if we want to prove it to ourselves, we undo the multiplication of 9 and y, so we divide both sides by 9. 9 divided by 9 is 1. 1 times y is y. 0 divided by 9 is 0. So the y-intercept is also 0. It's like, okay, that's weird. So my ordered pair for the x-intercept is 0. My ordered pair for the y-intercept is 0. What does that mean? This means the equation goes through the origin. Okay. So if the x-intercept and y-intercept are 0, 0, the line has to just go through the origin, which means it only has that one intercept, which is the origin. Okay. So there you have it. You need to make sure you know how to find an equation, or find an equation. You need to make sure you know how to find intercepts from an equation, from a graph, or from a table of values. Just remember the whole x and y coordinate, which one is 0. Okay.